Okay, here we go. Optimization again. You know, I'll be honest, I don't totally like that title. I mean, you can see the exclamation marks, it shows excitement. But again, just sounds like, almost like, oh, we're doing this again. When it's like, no, this is optimization. This is incredible. We should be excited about this. So maybe, thinking about it like The Return, kind of like a sequel. I don't know if that's better. I mean, either way, just, have some excitement. I do also want to warn you. I do apologize if I look a little faint or pale. I did just donate blood, so I'm a pint low. Um, so yeah, hopefully I don't pass out. Here we go. All right. This is just going to be practicing. So you at this point know how to do optimization. You are not quite an expert, but pretty confident in this incredible application of derivatives. So you're going to be doing a lot of practice here. Let's get going. First one, determine the area of the largest rectangle that can be inscribed. Inscribed, so what does that mean? That means the rectangle is inside of the circle. We want the circle to have a radius of 4. I'm going to have you try this on your own. I'm going to give you a hint to start. So to start, I would recommend drawing this on a coordinate plane. You do not have to, but that's going to be in my mind. And when I go through my explanation of the answer, I'll show you why. But kind of the easiest way to do that. And what I mean by that is center the circle around the origin. So, if I draw this, and then we can draw like a circle, right? And then I've got my rectangle inside, boom, 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 boom. And so now I can use the idea of the coordinate plane to kind of help me come up with some of my equations. Also, think about, as we talked about in the last video, is this going to be a closed interval, candidates test, or an open interval where we're going to need to justify minimums and maximums using first or second derivative test? My hint here for that is that the circle is the only thing that has the fixed dimension on it, right? So in that case, we need this to be legitimate numbers. We can't have a negative area, right? But, well, we could have no rectangle, right? So that's my hint that you're going to be doing the candidates test here. Okay, so I want you to try this on your own. Pause the video, unpause when you are ready to check your work. All right, so hopefully you got that the area of the largest rectangle is going to be 32 units squared. Perfect. No questions? Moving on. All right. I'm just kidding. That's the low blood talking. All right, so let's talk about this. So again, I would draw on the coordinate plane. Why do we want to do that? Well, it makes it easy so we can come up with the equation of the circle, because the equation of a circle centered at the origin is x squared plus y squared equals the radius squared. And this gives me a relationship between the x and y. The area of the rectangle then is going to be 2x by 2y. So that's why it's nice to use the coordinate plane if I can, if I don't know how to come up with the other equations. If I just put this in space, then I could still do this, but it's harder to come up with those equations on my own. So my equation for area is going to be 4xy. Now, I did talk about before we paused, okay, what are the bounds, right? So x and y are both bounded by 0 and 4, but they do include the 0 and 4. And I understand that then the rectangle is going to have an area of 0 in those instances. So that's probably not going to be the largest area, but you know what? It still is, there's nothing within the problem that's telling us we can't have that scenario. Okay, so I use the equation of the circle to give me a relationship between x and y. I don't care about the minus, right? So I'm only going to use the plus. So I substitute that in here for y, and then I get 4x times root 16 minus x squared. Now also notice that like in my diagram, I have opposite of x and x as these endpoints, but we're limited to 0 to 4 because I can't have a negative area. Now I went ahead and do the derivative. I need to do my product rule. So I did the derivative of the first times the second plus the first times the derivative of the second. In doing the derivative of the second, I need to do the chain rule. So that's how I get the red. I simplified a little bit to get the green. Now I want to get a common denominator so that I can set the numerator and denominator equal to 0 separately. So I went ahead, got a common denominator. That's why I went from the green to the purple. Now I can set the numerator equal to 0, set the denominator equal to 0. I get critical values, so x equals plus or minus 2 root 2, x equals plus or minus 4 as critical values. Again, I can ignore the negatives because I know that that's going to give me a negative area and it's not within my bounds that I previously established. So now I can do my candidates test, right? And really, I'm just going to use the positive 2 root 2, positive 4, and I'm also going to use 0 in my candidates test. So a of 0 was 0, a of 4 was 0, and a of 2 root 2 is 32. That's my area. As always, make sure we're going back and asking ourselves, well, what was the question asking us? So it wanted us to actually find the area, right? So it's not saying what are the dimensions that give us the largest area, it's saying what is that area. So make sure we are answering the question. Good times. Moving on. All right, this is fun. A rectangle is bounded by the x and y axis, and the graph of y equals 6 minus x over 2. What length and width should the rectangle have so that its area is a maximum? So here again, pay attention to what is it asking us for. Here it's asking us for the dimensions that give us a maximum area. Is this going to be open intervals or closed intervals? In this case, similar to the last problem, technically it's a closed interval situation. Here, it's telling us to use the xy plane. So the x-axis, the y-axis, and then what is this the equation of? That's the equation of a line. Okay, so again, I want you to try this on your own. Pause the video, and then unpause when you are ready to check. My hint, first draw the picture. Okay, so what do we got? Well, the dimensions for the max area should be x is 3 units and y is 3 halves units or 1.5 units. How do we come up with that? Great question. Well, like I said before we paused, first thing is I would draw a picture. So I draw the y-axis, the x-axis, here's my origin, here's that line, y equals 6 minus x over 2. And so that gives me my bounds then, right? So I can see, well, x is from 0 to 6, but again, I'm going to include those. Y is from 0 to 3, and again, I'm going to include those values. So then if I label this point here xy, then this side of the rectangle is x, this side of the rectangle is y, so my area is xy. What's my relationship between the x and the y? Great question. Well, since this point is on the line is my relationship. And remember, we've seen that before in previous problems this semester and last semester. So that's something where, again, the coordinate plane can help us out because that equation then is our relationship. So now I can take 3 minus x over 2, substitute that in here for y. I get my area equation. I distributed just to make it a little bit easier for the derivative. I can go ahead and do the derivative, and this is a pretty basic derivative, so I get 3 minus x. So my only critical value then is x equals 3. I want to point out, so again, here we're doing the candidates test, but if we needed to do a first derivative or a second derivative test, this would be a really easy second derivative because the second derivative is just -1. So I could see then that this would be a relative maximum. But we want absolute maximum. So we do our candidates test. A of 0 is 0, A of 6 is 0, and A of 3 is 4.5. Therefore, that is my absolute maximum. And again, if you were confused, I'm getting the 0 and the 6 from the bounds on x. Now, make sure we are answering the question. And as I mentioned before, it wants to find the length and the width. I used those, or I said those in terms of x is the length, and then y is the width, I guess, or height, so we got our dimensions. All right. You guys are quiet today. Must be crushing it. Okay, next, a canvas wind shelter for the beach has a back, 2 square sides, and a top. Find the dimensions for which the volume will be 250 cubic feet. That requires the least possible amount of canvas. So here I want to point out the volume has to be this. So now this is going to be open intervals. Now it still doesn't mean that the domain is negative infinity to infinity, but we don't have endpoints because we can't have 0 volume. You have your picture on the packet, so you can use that to help you label sides. Think about we're trying to use the least amount of material, so that would be surface area. Go ahead and optimize. Pause the video, unpause when you're ready to check. Okay, so what did we come up with? Well, I got the dimensions. The height should be 5 feet, the length should be 5 feet, and the width should be 10 feet. That's what you got too? Awesome, nice work. If you didn't though, let's talk about it. So we had this picture, right? I called this width, I called this length, and I called this height. You can call it X, Y, and Z if you want, it doesn't matter. But I know that the volume is length times width times height. I know that we have two square sides, so the length and the height are the same because this side and this side are squares. So I know the volume is width times height squared. I know that this has to equal 250, so this gives me a relationship between width and height so that I can come up with a surface area equation and get that equation entirely in terms of, in this case, height. So my surface area is 2 times the length times the height plus the width times the height plus the width times the length. We can see that, so I have these two sides, right? That's the length times the height, those are the surface area, and then width times height is the back, and then width times length is the top. Also notice my open intervals, all of these have a bound from 0 to infinity, because as one of them gets infinitely small, the others are going to get infinitely large, so that this equation stays 250. Okay, now I did a bunch of substitutions. So we know the length and the height are the same. So this becomes 2h squared. This became, again, the length and the height are the same, so I can call this height. So this became 2wh. But I know that w is 250 over h squared. Here I simplified this a little bit, and that's how I got my surface area equation is 2h squared plus 500 over h. Now let's go ahead and do the derivative. I get 4h minus 500 over h squared. Get a common denominator. So 4h cubed minus 500 over h squared. Set the numerator and denominator equal to 0. I get h equals 5, h equals 0. It can't be 0 though because that is not within my bound. So then I did an increasing decreasing chart. I can see that this is a minimum. So since SA prime of h is less than 0 on 0 to 5 and SA prime of h is greater than 0 on 5 to infinity at h equals 5 is a relative minimum. So then again, answer the question, what are the actual dimensions? So I need to find h, l, and w using my relationships up here. So l and h are the same, and then this is how I can find w. Similar to what I said on the first video, again, if you're using derivative speak, make sure you are addressing the correct variables that you're using. All right, last one. This is a good one. I love this problem, or this type of problem. Okay, so you have a new summer job as a lifeguard. Great. Your first day on the job, you hear someone in distress in the water at location B, so the person in distress is here. You are standing on the shore at location A, so you're here. The person in the water at location B is 40 meters from the shore, so this is 40, that is a fixed distance. You are 100 meters down the shore from that location, so this entire red line is 100, also a fixed distance. You know that you can swim at 5 meters per second and you can run at 8 meters per second. So how far should you run down the shore before starting to swim to save the distressed person in the least amount of time? So what are we trying to minimize? We are trying to minimize time. Notice that we also have rates and we have distances. So we need to think about what is the relationship between distance, rate, and time. And I know rate is distance over time. So therefore time is distance over rate. So that is going to be an equation I'm going to come up with. A couple other things we need to think about is this is definitely a closed interval, right? So one of the choices I could make is I could swim the entire way. So I could go right from here and swim here. I'm going to call that y. That is the largest y can be. Y could also be something in between. So this picture right here, this is just an arbitrary picture, right? This is not saying that this is the other option, right? There's any other option in between here that I could do. Or the least that y could be would be 40, because I could run all the way down the beach and then swim. And maybe that's my best option because I can run faster than I can swim. So now in terms of labeling things, I'm also going to call this distance x. So x is the distance that I'm going to run. Therefore, this is 100 minus x. So the least amount that I could run is 0 because, as we talked about a minute ago or a few seconds ago, I could just swim the whole way. The most that I would run would be 100 because I could run the entire way down the beach, right? I'm not going to run past that. That just would be silly. I can use Pythagorean theorem to find this value, and I know that the minimum value for y is going to be 40. Again, my equation that I'm trying to optimize is going to be time, and time is distance over rate. All right, I want you to try this. Pause the video. Your numbers are going to get kind of messy here. I'm going to just tell you that right now. Unpause when you're ready to check. Okay, so let's look at this. I told you we got a lot going on here. Okay, so first thing I did after we talked, right? So here's my Pythagorean theorem to show what is the maximum y could be. So this value here, right? And so 100 squared plus 40 squared is y squared. Square root of that is the square root of 11,600, which is 20 root 29, which is approximately 107.703 meters. So the bounds on y are 40 to 20 root 29. We already talked about the equation I want is time equals distance over rate. So my total time is going to be x over 8, because x is the distance I'm running on the shore. 8 is how fast I can run, 8 meters per second, plus the distance I'm going to swim over the rate at which I'm going to swim. Now, I need to come up with a relationship between x and y, because I don't want to have two independent variables. So if I look at this right triangle here, I know that 40 squared plus 100 minus x squared is y squared. I can multiply that out, take the square root. I don't need the plus or minus because, again, I would ignore the minus. So I know that y is the square root of x squared minus 200x plus 11,600. So I can substitute that in here. So this is my time equation. Now notice that since my denominators are constants, I can think of them as just a fraction in the front. So I can think, instead of thinking of this as x over 8, I can think of it as 1/8 x. So when I do the derivative of that, it's just 1/8. I can think of this as 1/5 times the square root of x squared minus 200x plus 11,600. So here's my derivative. So the derivative of x over 8 is 1/8. Here I'm going to do the chain rule. So I get 1/5 from this times 1/2 because I'm bringing down the exponent. The inside stays the same. Subtract 1 from the exponent times the derivative of the inside. Now I'm going to simplify this a little bit. So since this is 2x minus 200 and this is a 1/2, the factor of 2 here is going to reduce with this. So that's why I just wrote x minus 100 and then I only had the 5 in the denominator. And then I bring this down to the denominator. Now we need to get a common denominator. So I multiply the top and the bottom of this by 5 times root x squared minus 200x plus 11,600. And I multiply the top and the bottom of this by 8. So that's how I get this portion here. So here's my derivative. Set the numerator equal to 0. Set the denominator equal to 0. I started to solve the denominator and I realized using the quadratic formula that I was going to get imaginary solutions because my discriminant was negative. So I can just stop there. I don't need to find those imaginary solutions because they are not going to be critical values. But I do want to identify that I thought about it and, at least tried. Don't just ignore it. So in solving this, I want to isolate the root. So I brought the 8x and the 800 over here, square both sides. Just be careful with your math here. Use a calculator to help you if you need. So when I square this, 25 times this quantity, here multiply this out, I get this. Distribute the 25, bring everything over to one side. So this is kind of a big quadratic equation, but that's okay. Again, we're just going to use a calculator to help us if we need. I'm going to do the quadratic formula here. So opposite of b plus or minus the square root of b squared minus 4 times a times c over 2a. Multiply this out, I get 6,240,000. I can simplify that a little bit. that becomes 400 root 39. So then this reduces to 3,900 plus or minus 200 root 39 over 39. These are my critical values. Now I do want to type those into the calculator to see what is that decimal. So when I do 3,900 plus 200 root 39 over 39, it comes out to be approximately 132.026. I can ignore this because it is outside of my realistic domain. Remember, the maximum we said x would be 100 because I'm not going to run past the person down the beach. When I do 3,900 minus 200 root 39 over 39, I get approximately 67.974. Great, that is within my domain. So now I need to do my candidates test. And remember, my bounds were 0, 100, and then I'm going to use that critical value. I'm plugging those back into my time equation here. And again, I'm using my calculator to help me. Actually, a tip would be plug this into your y equals and use your table and change it to the ask mode so that you can just type these numbers in, 0, 100, and 67.974, and see what do I get. So when I type this in, I get 21.541 seconds, here 20.5 seconds, and here 18.745 seconds. So this is the shortest time. Answer the question. The question is, how far should you run down the shore? So the question wants me to know what is my x value. So you should run 3,900 minus 200 root 39 over 39, which is approximately 67.974 meters, down the shore before starting to swim to save the person in the least amount of time. Whew! That was good. Man, got through that and didn't even pass out. All right. So, conclusion. Identify what you're trying to optimize. Write it in terms of one variable. Identify the domain and determine if you need to check the endpoints. And, as always, have fun. Doing great.